And we're going to demonstrate the use of the central limit theorem in finding probability, and we're going to use Microsoft Excel to do it. Alright, so I'm going to go to Webassign. I'm going to show you the problem that I have selected here. So let me do that now. Alright, so here's our problem here. This is from Webassign. It says, suppose that the distance of fly balls hit to the outfield in baseball is normally distributed, and in this problem that means with a mean of 240 feet and a standard deviation of 50 feet. So we're going to randomly sample 49 fly balls. Alright. Now they're telling us that X bar is the average distance in feet for a sample of 49 fly balls. And we're asked to give the distribution of that sampling mean, X bar. So we want to round our standard deviation to 2 decimal places in here. So let's demonstrate how this is going to work. And I'm going to open up Excel here. Okay. And so, all right, let's enter in the information that we're given in this problem. We're told that our mean is 240 feet. And what's more, the standard deviation is 58 feet. Okay. And we have our sample size n equals 49 fly balls. So let's use the sample standard deviation to see how this works out. I had to turn on my light there, bear with me. Alright, so for our sample of 49 fly balls, this is going to be our sample mean as well. Let me drag this out here. This is also our sample mean. I'm sorry, our mean of the sampling means. All right. Now the standard deviation we have to adjust. This is where we do it. We're given a population standard deviation of all of our fly balls, but what we have to do is we have to adjust because we've got 49 randomly selected fly balls in our sample. So here's how we adjust it. What we're going to do is we're going to take our standard deviation of 58, but we're going to divide it by the square root of our sample size, which is 49 in this case. And that's going to give us the standard deviation. So this is the standard deviation of the sampling means. Okay, so the actual standard deviation that we have to work with is not 58 in this case. It is 8.28571. Now we're going to round that to 2 decimal places. That's more like 2.9 or 0.29 at the end of that. So we're going to say that X bar is a sampling standard deviation. Let me move this over here a little bit. Yeah. Trying to leave some room so I can see the chat as I do this if you guys have questions. Alright, so our standard deviation is going to be normal, right? We're saying that our mean is normally distributed. So we put an n to represent that here. For our mean, we're going to use the mean that we were given, which is our 240 feet. But now this time we're going to adjust because we're dealing with a sample size of 49. So that means we've got to use this number rounded to 2 decimal places, which is going to be 8.29. So that's what goes here. Alright. So far so good. All we really did was just adjust the mean of the sample size. Now let's see if we can use this for some probabilities, right? This question is asking us, well, what is the probability that 49 balls travel an average of less than 228 feet? Well, okay. So let's see what that means to us. What we want is the probability that our X bar, that's our mean, had, so if we took a sample of 49 balls, we're saying, well, what's the probability that that sample mean is less than 228 feet? Okay, so what we're going to have to do is we're going to have to find that using our normal distribution. Again, remember that the formula for a normal distribution goes norm.dist, and it includes our value of x, only in this case it's going to be x bar. We're going to put in our mean of our population mean, or in this case the mean of the sampling means. We're going to put in our standard deviation of the sampling means, which I'm abbreviating right here. And we're going to put true at the end of that because we want the cumulative distribution. So that's what our formula will kind of look like right here. So to get this value, here's how I'm going to type it in. I'm going to say, well, remembering that we want to probably normal distribution, we're going to take norm.dist. Here's the function right here. We're going to put in our value. It's for x, we're putting in that x bar, and we're saying that that's 228. So we're saying, what is the probability that a sample of 49 fly balls is going to have a mean that's less than 228 feet? Well, our sampling mean is 240 feet, and our sampling standard deviation is 8.259. I'm just going to click on the cell because, look, there's the number. Right? So we just put in cell B2 where that's located. And then I use true because I want the cumulative distribution. And so this is what that formula looks like now when I type it into Excel. All right, and this is going to give me my number. And in this case, there it is, 0.07377. And we want that rounded to 4 decimal places. So 0.0738 rounded up. Now, if we wanted to sketch a probability of what that looked like, what we're dealing with is a normal distribution. And what we're looking for is the probability that of less than 228 means that we're looking for this guy right here. Here's my 228-foot mark. And in this plot, the shaded area represents our probability that's represented right here. So it's going to be a pretty small probability. 7.38% probability, right? All right, so that's how we graph that. All right, here's the last question. This is sort of an interesting one. It says we want to find the 60th percentile of the distribution of the average of 49 fly balls. In other words, what we're saying is that, all right, well, what would be the distance that that the average of these 49 fly balls would have to go in order to say that 60% of all the other fly balls that we look at will be less than this amount? In fact, what we're given right here is actually the probability. We're told 60th percentile, so we're told that the area under the curve that we want is 60%. So let me go to Excel right here and just spell this out for you. We're told, well, we want the 60th percentile. And what that really means, that whatever value of our average is in this case, whatever it is, our x bar less than that value of x is already equal to 0.60. So in effect, we're working backwards. What is the x bar that goes with that given probability? So the function that we're going to use right here is called a normal inverse function. Goes like this. We put in norm.inv to say normal inverse. And in this function, we're going to put in our probability, the one that we know, and we're going to put in our mean, and we're going to put in our standard deviation of the sample means. Right? So when I put in my function right here, this is how I'm going to get this value. It'll look like equals norm.inv. And in this function, what they want is the probability. And we're told, well, that probability is 60%. So 0.60. Our mean, same as it was before, 240 feet. And our standard deviation, well, that was the one that we calculated before. So that's that value there in B2. And I'm just going to click on it, and I'm just going to use that value that it gives me. And so the value this is going to give me right here is going to be the value of the distance that these fly balls should be going in order to be within the 60th percentile. In this case, that's 242.099 feet. Well, if we're rounding it to 2 decimal places, that's 242.10. Alright, so that's how we figure this out. And of course, demonstrating, let's see that we got it. Hooray! There we go. So these are all our values here. And I wanted to spend a moment or two going over this with you. Let me go ahead and stop my video so that you guys have this now.